Hello students, in the previous lecture I told you for what type of problems, for what type of linear programming problems we cannot use simplex method and what are the modifications that we need to do for applying the two-phase method, like for converting the inequality constant equations into the equation form. What are the modifications that we are supposed to do so that we can solve that linear programming problem using two-phase method? Now in this lecture I'll discuss the two-phase method taking an example. So here it is a linear programming problem, that is minimization type of objective function subjected to three constraint equations. So the problem is minimization of objective function is equal to 10x1 plus 6x2 plus 2x3 subjected to the constraint equations minus x1 plus x2 plus x3 greater than or equal to 1, 3x1 plus x2 minus x3 greater than or equal to 2, x1, x2 and x3 greater than or equal to 0. So sorry, there are two inequality constant equations and the question and the linear programming problem is of minimization type. Now first what we need to do, as I have already told you, we need to convert the inequality constraint equations into the equation form so that we can solve it with two-phase method. Now as we can see, both the inequality constant equations are greater than or equal to sign, and as I have told you in my previous lecture also, if the inequality constant equation is of greater than or equal to sign, so for solving that inequality constraint using two-phase method, we need to convert it into the equation form by subtracting a surplus variable and adding an artificial variable. So here the first inequality constant equation has been converted into the equation form by subtracting an surplus variable and adding an artificial variable. Similarly, in the same way, the second inequality constraint equation has been converted into the equation form by subtracting a surplus variable and adding an artificial variable. So here S1 and S2 are the surplus variables and A1 and A2 are the artificial variables. So the equality constraint equations are minus x1 plus x2 plus x3 minus s1 plus a1 is equal to 1, and the second constant equation is 3x1 plus x2 minus x3 minus s2 plus a2 is equal to 2. Next, as we have introduced the surplus variables and artificial variables, we need to introduce those variables in the objective function also. So here the non-basic variables are x1, x2, x3. They were already given in the question that x1, x2, x3 are greater than or equal to 0. And the surplus and artificial variables that we have introduced, they are also greater than and equal to 0. Now we